Hello and welcome back to the Cisco CCNP route training from TrainSignal. We're actually going to be considering the second part of our lesson on route redistribution. Again, I'm Joe and I'm your instructor. In keeping with the outline that we used in our last section, we're going to be moving on to configuring redistribution and then verifying and troubleshooting redistribution as well. So configuring redistribution, we covered EIGRP already pretty exhaustively, from connected to static to the other protocols. We're going to do the same for OSPF and BGP. We're not going to specifically look at routing information protocol as a standalone protocol itself, although some of the same principles apply. We are going to be looking at OSPF and BGP, and then we'll actually be moving on to the configuration of redistribution in our lab environment. So configuring route redistribution in OSPF, we're going to cover connected, static, BGP, EIGRP, and other OSPF processes and so forth. So for redistributing connected routes, if you have a choice, and you can, it's better to use the network command in OSPF rather than to redistribute. One of the reasons why is, if you recall, redistributed routes are considered external and Type 5 LSAs are created. And by the nature of certain types of areas, stub areas for example, they're going to be filtered. So it might be a lot easier just to use the network command because there'll be OSPF internal routes. And again, it enables route interface advertisement and neighbor discovery automatically. For redistributing connected routes, you can just use the simple redistribute connected subnets command. Remember, you don't need to specify a default metric for this to operate. If you want to selectively redistribute, you can use a prefix list or a standard access list with the match IP address command in the route map, or the match interface command in the route map as we talked about before, and then apply it doing the redistribute connected route map, whatever the name is, subnets. Remember, subnets keyword, if it's missing, it's only going to bring in major network numbers. You can optionally set the metric if you want to change it. You can also use the metric type keyword, because if you recall, routes imported into OSPF are going to appear as E2 routes. If you want it to be E1 routes, you can use the metric type command in the redistribute statement in order to be able to specify that. Static routes. Simple redistribute static subnets is going to pull all of the static routes on that particular device. Or you can use the route map. We've stepped through this a number of times before. Access list, prefix list, match interface, route map. Apply it with the redistribute static route map subnets command. Use metric or metric type on this as well. If you're redistributing from another OSPF process, for instance, you may have OSPF 1 configured on your router and an OSPF 100, which is another process in the same router you want to share routes between for a variety of reasons. This again could have to do with wanting to have a trust boundary for a partner organization or a newly acquired company. You can just do redistribute OSPF, the process ID, and subnets. You can also use the match IP address command as we talked about before. Remember though, these will be imported as external routes. Make sure you have the subnets command. You can optionally set the metric or metric type. You might want to set a higher metric because if you don't want to be advertised back in. To redistribute RIP and BGP, again, because the process on the router is going to be almost identical. Redistribute BGP, autonomous system number, redistribute RIP. It'll pull all of the routes in. You can selectively do this with prefix lists, access lists, and route maps. We've stepped through this a number of times. Optionally metric or metric type for the imported routes. Very straightforward. Redistributing EIGRP into OSPF, you need to have the redistribute autonomous system number subnets command for everything, and then again match IP address, match interface, or match route type as well. Subnets, metric, metric type. Very similar to the process with the others, but we wanted to make sure you have a clear map of how this all should look with each individual protocol. Redistribution with BGP has some subtleties that set it apart from the other protocols. If you're redistributing connected routes, you can use the network command to advertise those rather than use the redistribute command. Remember, routes injected with the network command have the origin code of I, meaning IGP learned, and that's going to be part of the route selection preference process. These will be selected first. And it gives you more predictability and route in routing the advertisement process. If you recall, when we first configured BGP, we did the manual injection from the IGPs. We're actually going to remove those statements in our lab and then configure redistribution. We do redistribute connected for all the connected interfaces. And again, route map, prefix lists, and other mechanisms exist to be able to be more selective in redistributing routes. If you want to set the metric, you can. If you don't, it'll just take whatever the IGP metric is on the redistributed route, which could be good or could be a little unpredictable. For static routes, redistribute static IP. If you want to import all of them, if you want to be selective, again, route maps with access lists, prefix lists, and so forth. Redistributing EIGRP into BGP, redistribute EIGRP autonomous system number. Obviously, if you want to be selective, route maps, access lists. Redistribute RIP, very, very simple and straightforward. Same process, redistribute RIP for all routes, or you can filter them using an access list, prefix list, or route map. OSPF, you have to make sure that you specify the process ID and the correct one. Should have mentioned that as well with the EIGRP autonomous system number. Make sure it's the correct number. You can also specify the type of route to import, internal, external, and so forth, using the match command. You can also, again, use the access lists and route map combination to filter routes. So, as we get ready to configure our lab exercises, we're going to follow a pretty straightforward process. The first thing we're going to do is remove all of the network statements we put in previously. So we're going to leave all the neighbor configurations intact. We are not going to change any other BGP configuration elements, only the removal of the network commands. This is going to be the case on both router 1 and router 6. We're not going to deal with the internet router in this example. It's already pre-configured. The first thing we're going to do then is we're going to redistribute all the EIGRP routes, which are pictured on the left of the graphic. And just like the blue arrow, we're going to redistribute the EIGRP routes into BGP. We're not going to use any filtering techniques. We're going to specify a metric of 200 for imported routes, and the command will essentially be redistribute EIGRP 100 metric 200. We're not going to, in this part of the exercise, then redistribute BGP back into EIGRP. That's going to be a later exercise. We're going to do something different. So no filtering into BGP. A very similar process with the OSPF part of our lab pictured on the right. We're going to use a metric of 300 for the imported routes, but we are also, again, not going to redistribute BGP into OSPF. Now we consider the process of being able to take routes that have been injected into BGP and then actually importing them back into EIGRP in order to create full reachability. Similar process will be done with OSPF. But we need to filter, because otherwise we could create routing loops and ultimately a disaster. So the first thing we're going to do is we're going to create an access list to filter all those routes from EIGRP already advertised into BGP and keep them from being advertised back into EIGRP. So we'll use a standard access list matching the routes. We'll use a deny any. Remember, there's an implicit deny any at the end of every access list, but we're actually going to specify. It's another best practice type element. We're going to create a route matching that access list. We're going to set the EIGRP default metric. Again, it's going to be something important, as 1000, 2020, 128, 1500. There's no special significance to that. I just picked the numbers at random. And then we will use the redistribute BGP 65001 route map, the name that we're using. Almost an identical process with the OSPF section of the lab. We're going to set, however, the default OSPF metric as 10,000. So now we want to actually configure redistribution on the other side of our lab, the OSPF pod. We've actually created a configuration here. I want to parse through it a little bit. The first thing we want to be able to do is we want to be able to make sure that only these EIGRP addresses are going to be allowed from BGP back into OSPF. Remember, we've redistributed either protocol into BGP, but the protocols don't have any way of knowing what routes have already exist in their routing tables within OSPF and EIGRP, so we have to specify it for them. So unlike the previous configuration where we essentially denied all the EIGRP addresses, here we're actually permitting them. Notice routers 1, 2, 3, 4, and 5, the loopback addresses specifically permit, and all the VLAN addresses, and then some of the WAN addresses. And again, the idea here is to be able to permit. So we've defined that, we've put it here, And then we will finally need to do router OSPF1 redistribute BGP 65006 subnets route map allow EIGRP. So let's go ahead and apply this to our configuration. Let's do first show IP route BGP. Notice here that a lot of the things we want to redistribute are already present. 1, 2, 3, 4, and so forth. So that's what we want to be able to import into our routing table. So we start with configure terminal. First we define the access list. You could also do this with prefix lists, which is another way to be able to do it. There are a variety of methods available. So here we've defined our access lists. The implicit deny any at the end, which is already there, but we've specified it here. Now we're going to create our route maps. And the key point here is permit. If you remember, on the other side we had deny. So in this case, we're saying allow these routes. And next we go to our OSPF process and ask it to redistribute those into the protocol. Now, just for fun, we could put metric type 1, because if you remember, E2 routes are the default. So we put that out there. Now we could go into, let's do router 7 because it's downstream from router 6. So if we did show IP route, OSPF, notice that those have all been imported into the table, but they are now E1 routes. So that gives you a way of being able to verify the way that this has been reconfigured. So if we did ping 10.2.2.2, and it's successful. So this shows you that redistribution is working on both sides of our lab pod. Now we can actually wrap up this particular lesson by looking at verifying and troubleshooting redistribution. We've just configured our lab exercises. We did a little just brief test, but we actually want to look at ways that we can troubleshoot and verify that things are functioning as expected. Well, the first thing you have to do is verify redistribution by confirming that it is indeed active. Pictured to the left is the output of the show IP protocols command, and you'll notice that up in the upper left-hand corner, it says it is an autonomous system boundary router redistributing external routes from BGP 65006. Those are the types of statements you want to look for to make sure that, first of all, redistribution is active and that it's been configured. It'll be the same for all the protocols. If we were to scroll down and this was the actual active screen, we'd actually be able to see the redistributing from OSPF statement as well. Another thing that's important to do is to look at the output of the topology table in each protocol and verify the desired routes are present. For instance, in the way we set up our lab, we do show IPGB BGP to see the listing of the BGP topology table, show IP EIGRP topology, and show IP OSPF database as well. The other thing that's important is to make sure that the desired routes are indeed present. The easiest way to do this is the show IP route command with the keyword, the protocol that's being considered. EIGRP, BGP, OSPF. Picture to the left is a snippet from the routing table showing that very thing. So you need to verify the redistributed routes appear under the correct protocol. Now, on the routers doing the redistribution, it can look a little different than in the rest of the network just because, for instance, BGP has an administrative distance of 20. But also make sure that the complete routing table exists on all routers within the overall routing domain. If there are routes missing, troubleshoot and see what might be going on. And finally, confirm that networks are reachable. You can use ping and trace route to verify reachability. And again, to be able to sort of use a bulletproof test, use Telnet or SSH for application layer testing. Then you know that everything's truly functioning all the way up and down the OSI stack. Now, just a few troubleshooting items. If the desired routes are not present, check your filtering mechanisms, provided you've configured any. Make sure that the prefixes and masks are correct. It's often that numbers can get transposed, or sometimes if you do a lot of copy and paste, I've done this many times, you may have inadvertently pasted something in that's incorrect. Then make sure that the permit and deny statements are incorrect. If you're trying to filter out, you want to see deny. If you're trying to allow them, it's permit. You have to make sure the logic is correct. And then make sure that metrics or default metrics have been configured, for example, for EIGRP or RIP. Use the show running configuration command and look specifically for the default metric command underneath each protocol, or the redistribute name of the protocol and metric. Either one of those will allow the routes to be installed in the table, but if they're not there, then it won't. Another thing, just take a look and make sure that automatic summarization is not in effect. For OSPF, it's not a problem, but for EIGRP, RIP, and BGP, it can be a showstopper. Use the show running configuration command and make sure that no auto summary statement has been configured, or show IP protocols, and it'll say automatic network summarization is enabled, disabled, in effect, and so forth. If undesired routes are present, in other words, there are things in the routing table that shouldn't be there that you've specifically wanted filtered out, look at your filtering mechanisms, provided you've configured any. Make sure that prefixes and masks are correct, that the statement for permit or deny is correct. Sometimes it's easy to get the logic backwards. And make sure that you've used the correct statement in the correct place. So just some key terms. Redistribution, again, is the process of importing IP routing information from one routing source into another. A default metric is a manually configured value for a specific routing protocol used for redistributed routes, and it is required if you're using EIGRP or RIP. Metric type is one of the subcommands of the redistribute statement for OSPF, and it allows a redistributed route to be marked as either an E1 route or an E2 route. Remember, an E1 route is not only the path once it reaches the outside of the autonomous system, but also the path to get there. E2 does not take into account whatever the metric is to the autonomous system boundary router. Mutual redistribution is the process in which routing information is shared both ways between protocols, as opposed to one-way redistribution. And then subnets is a subcommand of the redistribute statement for OSPF, specifying that subnets of major networks should be included. Otherwise, you end up only importing major network numbers. So what have we looked at? We've looked at configuring redistribution for OSPF, BGP, and so forth. And we've gone through our lab exercises as well. We've also verified and done troubleshooting in redistribution. Thank you for your kind patience. We'll be moving on to other topics in our next lesson.